All right. So this is our part one of Install Fest that's really going through sort of intro to Linux and the command line. Um, and just to orient everyone in the curriculum very briefly, you can see that we have these broken up by module. You can see in each module there is a README file. And if you click on the link to get there, to the folder directory, it'll take you there. And each of the lessons, and each of these is one day essentially. And then we have some additional lessons like data structures and algorithms or computer science Fridays. And you can see a general overview of topics. And also, importantly, a link to some previous videos, lesson videos at the bottom. Um, and I do recommend reading through all this stuff in full. There's a lot of good stuff in here. So today's goal is later in the afternoon, we'll make sure that your environment is set up with VS Code and SQL and Python and JavaScript. But this first part is just going to focus on command line fundamentals and some overviews of operating systems, namely Linux or Unix. And this is the lesson
Uh,
that we're going to be working off of. Yes. Oh, did someone have a question?
yeah, I guess my mic is unmuted. I don't know. I'm on the GitHub, but mine doesn't look like that.
Um,
When I click, yeah,
okay. Remind me during break or at the end of class, and we'll take a look.
okay,
Actually, you raise a good point, though. You all won't need to follow along on the GitHub during the lecture. I'll be sharing parts of it, but I'll be writing code pretty soon. Um, Related to that, if you want to, you can code along for this, but we really don't design these lectures to code along. And unless you hear us explicitly say, please code along, we usually don't want you to. And the reason for that is simply time, just so we can move at a pace so we can cover everything. So again, this is not the worst one to code along to for some of this stuff, but that's not the intent and that's not the pace that it's going to move at. So if you have to choose, don't worry about coding along. I honestly think just like taking kind of, notes on a piece of paper and asking questions as you go is the best way to do it because you'll get more than enough hands-on time with all this stuff. So you all already have Slack and Zoom set up. Um, I do recommend signing up for this great nonprofit operation code that we link to here. Later in the afternoon, we'll do a complete Install Fest walkthrough for Mac users. And then for Windows users who are using WSL2, which is a virtual machine that then runs Ubuntu Linux, we'll walk through that as well. Both Mac OS X and Ubuntu Linux are, in essence, different flavors of this operating system, Linux. And Linux is really the open source version of this operating system called Unix that has sort of conquered the world. And you'll see Linux or Unix, and you'll hear those terms interchangeably used. Pretty much all the computers in the cloud run Linux. Wi-Fi routers, embedded devices. I think it's running somewhere on nuclear submarines. Linux is everywhere, and it's sort of the programmer's workbench. Um, and in fact, the reason why Macs became so common as dev machines that programmers use for local development is when OS X came out, and it was essentially a flavor of Linux. And I think the most well-known feature of Linux is the terminal, aka the command line. And for those of you on Mac, you can open up a terminal program. There's a great program called iTerm for Mac that I've installed. That's a terminal. For those of you on Windows, it gets a little more complicated because WSL2 is a virtual machine, and we'll go through how to set this up later. But you can open a terminal. But what I really recommend doing is opening up the VS Code terminal. And Mac users can do this too. And in fact, this is where we will spend most of our time. And I made this so big. There we go. So there's nothing in really in this file right now, but down here I have a terminal. And in VS Code, if I go to terminal, I can go to terminal, new terminal, and it'll open it up. And I can actually have multiple terminals in here, and I'll talk about that in a minute. I can also go to there, it's hiding there under view to open and close the existing terminal. And on a Mac, the keyboard shortcut is Control tilde, and it's something else on Windows. And I recommend just learning that keyboard shortcut so you can open and close this easily. But you're always going to want to have it open. And I recommend everyone just use the VS Code terminal for simplicity to get oriented, unless you've spent a lot of time on the command line and feel very comfortable. And we're going to dive into the terminal in a minute. But before I do, let me just talk a bit about like, what is Linux or Unix? What is the terminal? What is the shell? Why does this matter? And I'm just going to hit the highlights of what we have written here. I'm not going to go through all the details. In essence, Unix was created by Bell Labs in the 60s. And this was back when computers were big mainframes, like something that lived in a basement. And so if you wanted a team of people using a computer for whatever in 1962, personal computers didn't exist. We just had the one giant mainframe that cost $1 million and took up a whole room in the basement. And so in 1962, a terminal was literally something like this. And let's open up both of these images. And this thing was dumb. It didn't have a CPU. It didn't have RAM. It had a screen and a keyboard. And before this, the terminal was like a printer and a keyboard, and you typed stuff in, and then it printed out the output. So you had a bunch of these things that, again, weren't computers. They were dumb. They just connected to the mainframe. And you can see a sort of crappy diagram here. And so this originally a terminal was a physical thing. And as time went on and personal computers became a thing, the terminal program sort of remained. But the essence of Linux and Unix and the way it was designed is, and let me zoom in a bit here and start doing a little drawing. Let's say we had a mainframe computer, and then we had a terminal, and we had, I don't know, 4 people using their terminals. And so this operating system, Unix, was designed from the get-go to handle multiple users. And that's where you see a lot of these design decisions come from, though today it's sort of like under the hood. But that was kind of the world of computing back in 1960, whatever. And also, processor power was super weak. We're talking like not even like gigahertz, maybe not even megahertz. There was barely any, hard drive space. Like megabytes were precious. We're not even talking like gigabytes, like 1,000 byte. We're not, a megabyte is 1,000 bytes, right? A gigabyte is what, a million. We're not even talking like gigabytes, much less terabytes. And my MacBook Air has what does it have, like 50 gigabytes now these days, something crazy like that, or maybe even terabytes. So everything was precious and slow. And so all these command line programs that are now sort of the norm are from that era, which is why they all feel kind of arcane, because it was an era where it might take like a second for after you type something to see it show up on the terminal or for the program to come back. and where like every keystroke was precious. And there's actually nice things about this, but that's sort of the history behind why a lot of this Linux stuff feels arcane. And I just want to check in to see if folks have any questions before we keep on rolling. And let me just see a quick show of hands. How many people like know some of this history? A couple folks. How many people have like worked with the command line before? Right, and a couple folks. Yeah, and by the end of this course, you all will be super comfortable with it. And half of this course is just about getting enough hands-on time. You don't have to be a command line wizard to be a great software engineer. I know a number of really successful folks who absolutely are not. You do have to be comfortable on it, and there are some important concepts you'll learn along the way. The same people who invented the C language also invented Unix, by the way. Like Bell Labs kind of was firing on all cylinders. They also invented the transistor. Um, and so eventually in the 80s, hardware became powerful enough where I could actually have a personal computer, you know, on my desk, right? Or below my desk. That was actually a computer and not just a terminal to a mainframe. Linux wasn't created until maybe the late 80s. It was made by this grad student, Linus Torvalds, and he named it after himself, Linus Unix. And it became an extremely popular open source version of Unix, so it didn't cost money. So suddenly all these academics and researchers started using it, and then it kind of conquered the world. And now there's many different kinds of the Linux OS called flavors. Ubuntu is one, and that's the one that's installed with WSL2. Mac OS X, I think, is based on Debian. Windows is not Linux based, but they've done a lot of work with WSL2 to make it really easy to run a Linux virtual machine. So Mac OS X, very similar to Linux, has some differences. Windows, not Linux at all, but they now have a great virtual machine for it. And then Linux is Linux. Not just Linux, but really any operating system we can think about as having different layers. And let me go ahead and grab an annotator here. And here for applications, think Chrome, right? Like a browser, or VS Code, or Zoom, and so on and so forth. The shell we're familiar with as the command line. And the shell, in fact, has its own programs. The kernel of an operating system has programs that we don't directly interact with for core stuff, like displaying pixels on a screen, handling mouse and keyboard input, networking, i.e., like over the internet, or Wi-Fi or Bluetooth, or reading from the hard drive. So the kernel of an operating system does lots of really important stuff. And even an operating system with shared users like Linux doesn't need separate stuff for each one of these. In fact, it's better for everyone to be using the same thing. And another important thing that the kernel does is keeps one program or user from deleting another program's or user's stuff, right? I don't want Zoom being able to go in there and delete all my files. I don't want, my friend's account that I made on my computer being able to go in and delete all my stuff. So the kernel does a lot of sort of, you could think of it as security focused stuff, but it's also like, what if the people who write VS Code, Microsoft, make a mistake and VS Code accidentally starts eating up tons of memory? Well, the kernel of an OS is what controls what this program has access to, so that even if someone has screwed up in writing some VS code, it isn't going to sink the whole ship, which used to be a real issue back in the day. And then for hardware, we might have, like Wi-Fi drivers, our solid state drive drivers, and stuff like that. And so you can kind of see these layers and see how there's sort of levels of protection. Like as a user, we don't really want the user to mess with the kernel, right? There's not a lot of value in that. And so what we do is the user gets the shell. The shell protects the kernel. The user interacts with the shell. And this is where this term shell program came from, which you may or may not have heard of. A common shell is called bash. Let me right. And these terms kernel and shell come from Unix. They were invented by the same people that came up with Unix. And there's different kinds of shell programs. Like Mac now has this shell named ZSH installed by default, and we'll learn, and Windows folks, you will install ZSH as well. And all these shells sort of have similarities. There's something called POSIX compliance that we don't have to worry about, but they're all similar in the important areas. So if I
On the note, you said that the shell protects the kernel and the user interacts with the shell.
exactly,
Okay.
exactly. And the shell program is also what lets me interact with the computer as a whole. And these days we have really nice graphic user interfaces. And on the Mac, I can go to the Finder, and let's open up a new Finder window. And on Mac and Windows, we have this really nice graphic user interface. I can go through, I can see all these different files. I can see different programs. I can see what's in the desktop. But a couple decades ago, that didn't exist. And if we're working with a server or virtual server running in the cloud, there's no need for it to run a graphic user interface, a GUI. We probably just want a text-based interface. And so these days, a terminal isn't like, a physical machine, but it is itself a program. Like Mac has a terminal program by default. There's another Mac-based terminal program called iTerm that I like. And then VS Code has a terminal program as well. And all of these things run a shell program. And I'll talk more about the shell later. The main thing to know is, though it feels kind of weird and different, the shell on the command line actually gives us its own little programming language and its own environment. And right now here in this VS Code terminal, I've got 3 different shells running. And if I wanted to here in the iTerm shell, I could open up another shell session in my terminal program. So the distinction is a little subtle and it's not critically important, but it's good to be aware of. And the same way that with Finder, I can look at I have like a zillion screenshots from just screenshotting stuff for class. I have a downloads directory. I have a documents directory. I can look at my file system from the shell, from the terminal. If I type print working directory, I see what directory I'm currently in. If I type ls for list, I see a list of all the files and directories in my working directory. And if I want to, I can then list everything inside one of these directories. And it's the same stuff I'm looking at over here if I look at my desktop, just with a text-based interface instead of a GUI, a graphic interface. And I can even change my working directory to navigate into another directory with the desktop. And whether it's with the terminal shell or iterm or our VS Code terminal, they're all interacting with the same thing, right? Now, Windows WSL2 folks, your VS Code terminal is going to be inside your virtual machine. So you have to take everything I say here with a little bit of an asterisk, because you can't open up whatever the Windows equivalent of Finder is and look at the files in your virtual machine. So this only applies to Mac people, but you certainly could open up multiple terminals. And over here, I can navigate to the desktop and see all my screenshots. And if I wanted to, I could use this command touch to create a file. Because back in 1960, someone thought creating a little program named touch to create a file would be clever. And now that's become the standard. And I can name it whatever I want. It doesn't need a file extension. I'm going to give it .txt just for fun. And now if I hop over here to the Finder, and again, WSL2 folks, this won't quite work for you because you're running a virtual machine. So it really is two different file systems. I've got my new file, and I can type something in it with text edit. And let's just say hello world and go ahead and save this and quit this. And now, if I wanted to, I could use the code command, which from the command line will open up VS Code to open up my new file, and then I see it right here. I could also use a command line command called cat, C-A-T, which prints whatever's in a file to the terminal. And then, if I want to, I can navigate, I can see what directory I'm currently in with print working directory, and I'll navigate back to where I was in a minute. We'll talk about that in a minute. But I just want to check in and see what questions folks have thus far with this sort of more conceptual overview, along with a little bit of coding. What's on people's minds? What are people curious about?
What if you open a file that has a picture?
Yeah, it's a great question. I'm actually not 100% sure, but I know there's a bunch of these screenshots in here. I'm just going to copy. I think this is the name. Now, here's the trick question. By open, do you mean open with VS Code or open with what program?
I guess in the shell, if you touch it, no, touching it creates the new one. If you cat it, I think was what it just said.
Yeah, great call. Um, let me get the file name right and let's find out. Cat, uh, so the other nice thing about the shell is what I'm doing right now is I'm actually hitting the tab key. And as you type out file names or directory paths, it will auto-complete for you based what's in there and give you hints. So I have like a zillion screenshots. So I'm just trying to find one. And there we go. And note the way that you have to show spaces on the command line is with this / in front of the space because it's sort of a special character, which is a pain, which is why people usually avoid spaces and file names for stuff that we're interacting with through the command line. And so now I think I've got that. Yeah, and that's a great question because we get something printed, but it's actually not that useful. And if I make this bigger, and let me go ahead and clear this and run the command again just so we can see it. And I'm pretty sure what we're seeing here is like that, that .png file image has some sort of format. Maybe it's binary, maybe it's not quite binary, like hexadecimal. And then the cat command is doing its best to print that out. And as you can see, it's pretty gobbledygooky and not very useful. So it'll print it out, but it's just not very useful to us. Yeah, so that's a great question. And that touches on a really good point. Everything in Linux is a file or a directory. And so you can pretty much use any command from the command line with any file. It just won't work that well with some of them, right? And cat isn't going to be very useful for files that aren't in like a human friendly readable format or in some format that's meant to be read by some other program, like whatever the image format is. And VS Code is actually, I must have screenshotted this to show someone something about GitHub. VS Code must have baked into it, it's got all these cool extensions and features. And so it knows how to read this image file and then it actually renders the image. But Cat actually showed us the closest equivalent to like the text of what's in there. Yeah, great question. Great question. What other questions do folks have? Like, what are you all curious about? What's on people's minds?
When you're just like navigating through the files GUI on your Mac, for us Windows people, that we would be doing that all through like Ubuntu for the virtual machine, right?
Correct. And this afternoon in the Install Fest, we're going to set up all the WSL2 people's VS codes so that every time you open up the terminal or open up a new shell in the terminal, you're always going to Ubuntu. WSL2 people, you should be able to, like if you click right over here next to the plus, there's a bunch of different options, and one of these should say Ubuntu or WSL or something like that. For Mac people, the default setting, which should be ZSH, is exactly what we want. Yeah, great question. So let me close this Explorer for a minute. We'll come back to it later. In Linux, there's really two things. There's folders or directories, and there's files. And with the shell, we can interact with the operating system, and we can see all the files or folders in the directory we're currently in. CD lets me change directories. Now, if I type CD just by itself, it does something a little special. That tilde that you all see over here, see what I'm talking about? Where the command prompt is, that indicates I'm in my home directory. And WSL2 users should see something really similar. And this is my Mac username. And this is the list of a directory that holds all the user directories on this computer. And there's a bunch of different ways to get back to the home directory, and it's where you're going to want to do most of your stuff. I can type CD no matter what directory I'm in, and it'll take me there. An alias or shortcut to the home directory is also ~/. That'll always take me back to the home directory. For instance, if I go into code, and let's go into code platoon curriculum, I'm going to type clear just to clear the terminal. And I'm going to type print working directory, which I do all the time, and which I recommend you guys just doing all the time to orient yourselves. If I look here, I can see that my home directory is 2 levels up from my current working directory, right? The current directory is this one, code platoon curriculum, but a level up from that is code, and then a level up from that is my home directory. And let me see if I can't visualize this. I think the easiest way to visualize it is just going to be with TL draw or a diagram from here. So a directory structure is actually a tree. If I make a little diamond right here. And let's have this be users. And let me navigate up. Change directory ... or if I want ... /, that's going to move me one level up. If I just did dot by itself, that keeps me where I am. One dot is my current working directory. Two dots or two dots and a slash takes me a level up. If I navigate a level up again into the user's directory, let's see what's in here. And so at some point, I made another user named ZR or something. And so if we're drawing our file tree diagram, and the file system indeed is a tree data structure, it would look something like this. And everything I care about is in my user's directory. And again, I can just type cd. And because we hop back to the home directory so often, cd will take me back there. If I wanted to go even further up to the root directory of the whole file system, I could still type cd to go back. I could also use the tilde slash as an alias or shortcut, because you'll see tilde as an alias for the home directory. And that way, no matter what user I am, cd or cd slash tilde always takes me back. cd space dash, by the way, takes you back to whatever directory you were last in. And when you hear root, what it's referring to is the root of a tree, because the idea is this structure is sort of like the roots of a tree going down. This mainframe stuff, let's just pull that out of the way. Where we have users, and what else is there? Like application, library, system, bin. I'm not gonna draw out everything, but I'll just throw out one or two. Bin, I think, is good. And let's just do library, just for fun. And maybe application. Right, and we don't always think of like a file directory as a tree structure like this, but this is actually how it's organized, and this is what we talk about when we talk about moving up a level or down a level in the tree. And let me make this nice bright red. The working directory is whatever directory I've currently navigated my shell to, because that's where commands will get run from. So right now, if I print my working directory, I'm up here in the root. And someone tell me, what's the command if I want to navigate from here into this bin directory?
cd bin.
Yeah, cd space bin, just the name of the directory. And if I look in here, there's actually a lot of really interesting programs. mkdir, make new directory. ls to list what's in a directory. We've seen that one. cat, which we saw. bash, which is a shell program. zsh, which is the shell that we're actually currently running. cp for copy. There's actually a bunch of commands in here. And all of these command line commands are little programs. So ls is actually a little program, and bin, I believe, is short for binary, as in like a program in essentially a binary format that we can run and execute. So if I wanted to create some new program, like, do this, that I could run anywhere, I would put it there. And we're not going to have to worry about that, but I want to kind of give you guys a bit of a tour. And so now we've changed our working directory to be bin. And just to share with you guys, I've already made some directories in my home directory. I have one named code. And inside code, I made one for Zulu Platoon that I just named Zulu. And inside there, I cloned a GitHub repo that I just made called Zulu Demos and Notes, which is also a directory. So this we haven't really gone over yet, but if I want to navigate from here all the way over, not just to users, not just to Adam C, not just to code, not just to Zulu, but to Zulu Demos and Notes, how can I do that in one command? And for those of you who are new to the command line, you'll be learning this. This is a question more for those of you who have done a little bit on the command line. Well, I know I need to use change directory. Someone remind me.
Path.
Say that again.
You could type out the entire path.
And what do you mean by the entire path?
So, well, I'm not sure how you would separate the doing CD to get back to the root directory in order to go to users. Can you use a comma or something?
Close. But
Or
by entire
semicolon?
path, do you mean something like this, like users/Adam C?
Yeah, just continue to go down the tree with separated by a forward slash until you get to the directory you want.
Yep, totally. And Tim, that was you, correct?
Yeah.
Okay, I didn't have the Zoom grid open. That's why. So I'm still getting names and faces connected. And yeah, so Tim, this is a great call. And I'm going to talk about the two ways to do this in just a moment. What we're doing now is called an absolute path. And you can always tell an absolute path because it starts with the root of our file system tree. And that's the cool thing about an absolute path is because we have this sort of tree-based data structure, every absolute path is going to be, I don't want to say unique. If we have two things with the same name in the same spot, then we might have an issue. But it's a unique address, right? And Tim, like you were saying, I can do users, and I'm using tab here to help me because I'm lazy and I want to avoid typos. My username, code, Zulu Demos and Notes. Awesome. Good job, Tim, and thank you. And note that print working directory command prints the absolute path. And I just want to check in and see if folks have questions here, because I just threw like two big concepts here. One is the idea of absolute path, and the other is that this change directory command, like, basically that a file path is a whole big thing. It doesn't just have to be a file in our current directory or a level up. We can give it a path to any file on our system, and change directory can take us there. So I just want to check in to see what questions folks have. Okay, cool. So I'm here. If I type ls, I see readme. Awesome. I do cd space dash, which is a shortcut to take me back to whatever directory I was just last in, which took me all the way back to the bin directory. I want to get there again, but I want to do it a different way, not using an absolute path.
Can you just change directory straight to where you're trying to go, like a direct path, I guess?
So you mean like CD, Zulu, demos?
Yeah.
Unfortunately, I cannot. Because when I'm typing this, what I'm really typing and what the shell kind of puts in there under the hood is a // at the beginning of this. For instance, let's say I cat cp. Now, we're not meant to be able to print this out and understand it. But what that cat command really does is /cp, where the / indicates my current directory, inside my current directory. Right. And since the Zulu demos and notes is not inside my current directory, I have to give it a path to get there. And the one way was the absolute path. The other way to do path stuff is with what's called a relative path. And in fact, we've already seen that, because if I do ls space /, I'm saying print out all the files in our current directory. If I do ls space /, what did I just print out a list of files and directories from?
The directory above you.
Right. And I think
So-
many of you have seen the //
So you could change directories to one that's adjacent using a .. and then that directory name.
Yes, very close. // takes you a level up, right? // takes you a level up. And that's relative, because if I was in the library directory, or cd/library, and let's navigate there with an absolute path. Well, it just so happens that a level up from library is the same thing, but the // goes a level up from whatever directory I'm currently in. I just want to check in to see if folks have any questions around that, if that makes sense. And I can do this not just with ls, but with any command on the command line. I could do cat .. bin cp. And this doesn't do me a lot of good to print out the cp command. Maybe instead I want to do ls space .. bin. And what did I just tell ls to do? I told it to go a level up and then down into the bin directory. So I can use relative paths to go up and then down. So to go from my current location of /library off of the root to Zulu demos and notes, to navigate the working directory there in one command, not using an absolute path, I need to tell the cd command to go up. We're going to go up a level, right? And that would take me to the root directory. Let's go back to the library. We go up to root. We go down to users. And note that the tab autocomplete helps me here. I go down into Atom C. I go down into code. I go down into Zulu. And then finally down into Zulu demos and notes.
That seems like an absolute path to me still.
It's really close. The difference is these two dots here at the beginning. And you're right that in effect, what we did was we used relative to go up, but from this point on, it was an absolute path, because that's just what the path happened to be. Let me show another example of this, though. Let me hop back to the library directory. Let's use tilde, which, I said once or twice, this is an alias for the home directory. And this is what I mean. Oh. And let me try PWD so we see what we're here. CD tilde /code/Zulu demos and notes. right? Again, my working directory is back over here in library. And that tilde is sort of an alias, or you can think of it as a nickname for my user's home directory. And that's a terrible tilde. I apologize. But you can see how everything else in that path is based off of that. And now if I run this, it takes me to Zulu's demos and notes. Does that help illustrate, Jack, to like the difference between absolute and relative paths? Awesome. Yeah. And that was a great question too, because you're absolutely right that, we use the relative path to go up, but from that point on, it was really absolute. But that's really the power of relative paths. So you all will be using a whole lot of relative paths for short, simple jumps, a lot of CD /... You'll also see CD space ... /... Right? And if I'm over here in Zulu demos and notes, where do you guys think that command will take me to?
Is it code?
Code.
Yeah, exactly. Nice. Right? Relative up 2 levels. ... / takes us up 1. ... / takes us up 2. We're in code. And so I could do ls ... / as well. And that would list out everything in the code directory. So relative paths are your friend. And the key here is just practice, I think. How are people feeling? And do folks have any questions on relative paths, or really on anything else that we've been covering?
Pretty good. I mean, I know for me, like doing the foundations of programming, I already got like kind of hang of this stuff. And it's pretty simple, I think, too.
Yeah, once you've done it enough, it's simple. I graduated from college in 2007, so I'm totally dating myself here, but I do remember a lot of this stuff definitely felt like Greek to me, like the very first time that I was introduced to it. But I will say, like, the more you do it, the more you internalize it, and then it does have a logical consistency for the most part. So it might be slower in the beginning to do everything on the command line, but kind of force yourself to, because it'll help you get more comfortable with it. And also, don't be afraid to use tab to help autocomplete stuff. And I just type pwd all the time. And just to do a bit of review, we've seen that absolute paths start with a slash because they start from the root of the file tree. We've seen that a relative path could start with a tilde to start from the user's home directory. A relative path could start with 2 dots to show a level up. It could have as many levels up as we want. And that when I type ls by itself, that is in fact a relative path. Just under the hood, the shell is doing the work for us of /. And so, if I want to, let's say, create, let's create a directory with the mkdir command. And I'm just going to call this foo. And let's create a file in that directory. We'll call it hello.txt. And now I could do code /foo hello.txt, and that will open that file up for me. It's pretty normal to drop the / most of the time, and you'll just see this, but this actually gets the / added at the beginning. So both of these are actually a relative path. And I can type in here hello world, and I can go ahead, I can save my program. And now if I type ls, I see readme and foo. You guys will see soon files called .gitignore files or dot files. We can use these files to ignore things that we don't want Git to keep track of, which we'll learn more about later. So don't worry too much about what's in here. And I could make a dot file for anything I want. And I can print these out with the cat command. Cat.gitignore. And in fact, this cat git is a directory is something we're going to see in a second. If I type ls for list, I don't see these dot files. They're there, but by default, the ls command does not print them. Shell commands have something called flags, which you all have probably seen even if you didn't know the word. Raise your hand if you've ever seen a command line command where after it you put 1 or 2 dashes and something. So this is a flag. And if you haven't seen it, don't worry, because we're going to be doing it a ton. I don't know what the -a stands for, but it's kind of like an extra argument. And that command will show the dot files. There is also ls-l. And this shows a lot more information about each file, when it was created, and permissions stuff about it that we don't have to worry about right now. I can even combine the two. So I see the dot files and the extra information. And note that there's a directory here named .git that was created when I cloned the repo. There's actually files named .dot and .dot. And these are actually aliases, and that's actually how relative paths work in Linux, but we don't have to worry about that. This is where the command line stuff does get a little arcane. There is on the command line a program called man, which is short for manual, and it will print stuff out. And if sometimes you'll end up here, and if you see this little colon here, that tells you you're kind of in like reading mode of, it's actually the cat program. The up arrow and the down arrow move you around, space bar pages. And this is incredibly comprehensive, but frankly difficult to read. The most important thing to know is Q quits. What's a lot more useful is what we have linked to. And in this lesson, we list all these core commands and these variations. So again, I do recommend having this out as a reference. And here's the relative paths and some illustrations. We've talked about absolute and relative paths. We've talked about file management. I'll talk about copying and moving and deleting files in just a moment. Many of you have seen the sudo command. We'll talk about the clear command. I'm not going to really worry about symlinks too much. These we don't need to worry about. These commands are less important. But this is nice. And it's a website called Explain Shell. It explains what a command does. If I put in an argument, it'll give me more information about it. If anyone can recommend a good shell reference as well, please throw it in the chat. I'll look for a couple others. But I recommend just keeping this open and putting things in here. And honestly, I think this is where, well, you don't even need ChatGPT. You can, but if you just type Linux list all files, the Google search results are pretty good these days. And if you use a tool like ChatGPT, I don't recommend generating code with ChatGPT. Do not copy and paste code. Do not use ChatGPT to generate code because it will hurt your learning. But for helping to explain this stuff and figure out how to do command line stuff, absolutely, go for it. And what you'll find is that since the internet was created by programmers, if you pretty much any programming related question you Google, 1,000 people have already asked, and you'll find a ton of great resources very, very quickly. Right. So I think Googling these things and getting used to that is really important. Let me just quickly walk through those other commands. So one of those commands was copy. And let's say I want to copy this hello.txt inside the foo directory. Let's say I want to make a copy of it in my current directory. I can just do dot, which says copy this file with the same name where I currently am. And now I see I've got hello.txt. And if I want to delete it, I can do rm hello. Maybe I want to copy it into this current directory, but I want to give it a different name. Maybe I want to navigate into foo and I want to copy hello and I want to give it another name in the same file. Maybe I want to rename hello. Well, Linux doesn't have a rename command, but if you use the move command, mv, it will do the same thing. And it looks like I accidentally deleted hello, which is perfect. So let's move another hello to the same location, but let's give it a different name. And if I wanted to move it a level up, I could just do that. And now if I print out a level up, I see that it's there. And I do recommend, as you're working on this stuff, have the VS Code Explorer bar open. And you can set it to use a base directory. Like if I do code dot, it opens VS Code in this current directory and sets the editor to here. Another useful tip is if you right click on a file or a folder, there's this command open an integrated terminal. That opens a new terminal whose working directory is set to wherever that file or folder already lives. So if you get, disoriented on the command line, that's a really useful tip.
Can you close a command? Can you close an open file in VS Code using the command line?
I don't know. The short answer is you wouldn't want to, because you would just use a VS Code keyboard shortcut for that instead, which I think is Command W. Like if I do Command W, that closes it. Yeah, I don't think you can close a file because once you open it in VS Code, the shell program, it doesn't know anything about what VS Code is doing. VS Code knows that the file is open. Does that make sense?
It does. What about navigating using a keyboard shortcut from the terminal back into the VS Code window so that you could then close it using that shortcut?
Yeah, totally. So Control tilde opens and closes the terminal, which is a bit of a pain. You can customize it so instead of opening and closing, it shifts focus. You just have to Google how to do that and change it in like a VS Code config file somewhere. For what it's worth, I do pretty okay with this way, but I agree in a perfect world, it would be nice to have the toggle rather than the open and close. The VS Code shortcuts let you like focus on different windows and stuff like that too. To be honest, I'm not a VS Code shortcut expert. I also use this thing Vim mode that has like all these different keyboard shortcuts, but VS Code has keyboard shortcuts for pretty much everything, and you can customize them. And that would actually be a great thing if you wanted, if you customize it a bit and you wanted to demo that to the class at some point. Yeah, I definitely do recommend like taking a little time to learn the VS Code keyboard shortcuts. I honestly think probably going to their website and just watching their tutorial video is the easiest way to do it. I do use the mouse for clicking between these two, and I don't think that's the end of the world. What other questions do folks have, or what else is on people's minds?
This isn't related to the lecture, but that books and lectures shared drive thing you posted, I don't have access. I'm sure other people probably don't either. I messaged you, I guess, right
Oh,
after the last break.
thank you for letting me know. I may need to add you guys as a group to that. I will do that right now, in fact. Give me yeah, give me 1 second here.
I also don't have access to a repo.
The repos we'll tackle during the install fest later on. I think I would ask just have you accepted the invite on GitHub? I would check your email for an invite from GitHub and make sure you've accepted that. You all should now have access to that lectures and books. If it's not working, let me know. The GitHub repo stuff we will circle back to in the afternoon. But step one, because I think most people do have access, is check your email. Check the spam folder, look for a message from GitHub inviting you to a GitHub org. And if you don't see any, then let me know and I can resend the invite. I think the last thing I want to mention is let's talk about copying directories and deleting directories. So I've created this foo directory. If I copy the directory, I get this kind of message that's pretty arcane. What it's telling me is I need to tell the copy command that we're dealing with the directory. And I need to use the -r flag, which stands for recursively, as in also copy everything inside here. And I'll just copy it into a directory named bar in our current directory as well. And now if I look, oh, well, I didn't put anything inside bar. Let's go ahead and delete bar. And note, if I try to delete a directory, I get the same message. So let's do rm space r bar. And let's copy hello.txt back into foo. And now let's try copying foo again. And now if I look in this bar directory, I see I've got hello.txt. Now, the -r is recursive for deleting. If I did rm-rf bar, F stands for force. And what the F does is, like, if I have a directory with a bunch of things in it, I might get prompted, especially if I have multiple levels. Force will override that and just delete everything. Sort of the classic play a really mean prank on your programming buddy joke is to give them this command, which I'm not going to execute, and none of you should execute. I am going to paste it in Zoom, but don't copy and paste it. Don't run it. Anyone want to tell me what this command does?
Does it delete your root directory?
Yes, it does. And what's in the root directory? Not a trick question.
Everything.
Exactly. This will delete everything on your file system. Now, maybe Mac OS X will prompt me to type in my password and use sudo, because for certain commands, you need to do it as the root user, which is Linux speak for administrative user or super admin. But I think I already have root privileges just because that's how this is set up. So, that rm-rf/ command might actually work. And if I did this, and to be honest, I feel a little antsy just even typing this. This would prompt me for my password. And if my user account has like super admin or root access levels, then it would accept it, and then it would delete everything in the file system. So, you know, WSL2 folks, you're kind of okay, because worst case, you can rebuild the VM. But everyone else, most programming stuff, there's a lot of flexibility. Like if we write some code with an error, especially learning, it's like, who cares? We can fix it. We can debug it. On the command line and with Git, we do have to be a little careful because these tools are powerful. So just my rule of thumb with the command line is I never run a command unless I'm 100% sure I know what it does. And if I'm only 90% sure, I ask someone and I double check and I take it slow. Because it's also easy to, you know, maybe copy something and make a typo and overwrite a bunch of files when copying. Now, the odds of doing this are pretty darn low, especially with all the assignments that we have you doing now. But I do want to mention it just to emphasize it's important to pay attention and be thoughtful about these commands because there aren't really like a ton of safeguards around the command line commands. So I will always double check command line commands before I run them. I try not to, you know, do stuff when I'm tired. That's also why I like to back stuff up to Git. And again, like, you know, especially if you're borrowing something from ChatGPT or the internet, make sure you take the time to read through it and think through what the command does before you run it. I think that's probably a good stopping point because it's 12:30 and I apologize. I did eat into our lunch a bit because I think the plan is for us to reconvene at 1:15. So why don't we stop here and I can take questions. If anyone has questions, I can stick around for a bit. But otherwise, if we break now and reconvene in like just over 45 minutes at 1:15 for the second part of Install Fest, does that give everyone enough time to grab some food and recharge themselves? Okay, awesome. Last thing I want to very quickly show you is the assignments for today's lesson. So these are relatively straightforward. Please do them. Just write out the answer to these. Practice some navigation. I really like this program, Terminal Tutor. I would get as far through this as you can. And then we have just a couple exercises here to do. And even if you've done foundations of programming and feel pretty comfortable with this stuff, just do it. Because if you know it really well, it won't take you very long. And if it takes you longer than you think, then you didn't know it as well as you thought. Right? So there's really no downside to doing it. All right. After our lunch break, we'll reconvene at 1:15 Central. We'll break into two groups for Mac and Windows, and we'll do system setup where we'll tackle everything with VS Code and GitHub and getting the system set up. Thank you folks very much. Have a great lunch, and I'll stick around for a bit if folks have command line questions or things that you want to go over.